Okay, good evening, everyone, and I'm very pleased to have today's interview. So I will start by saying a few words on Photon Hub Europe. First, funded by the European Commission, Photon Hub Europe seeks to boost the competitiveness and uptake of photonic technologies across Europe. And you should get in touch with Photon Hub if you are a company innovating in photonics and are interested in topics such as grant funding, technical support, business and investment readiness, training, or access to advanced research centers. Focus on these technologies. So, for instance, one of the highlights of the programs of Photon Hub Europe is the online investor days, which are dedicated sessions which provide beneficiaries with a platform to pitch their ideas and connect directly with potential investor. It can be an incredible opportunity to showcase your vision and secure the funding your business deserves. I also want to take this opportunity to remind people that the Photon Hub investment readiness coaching and investor matchmaking session is open until December 22nd. So the deadline is quite soon. So if you are a deep tech startup dealing with technologies with photonic technologies, you might consider that. So maybe you have a growth plan which requires funding so that you can take your business to the next level. If that's the case, I invite you to apply to this investment readiness coaching and investor matchmaking program. It's a one-of-a-kind program which will help your company find investors and help you pitch your solution to them. With this program, you will have a unique opportunity to learn how to present your financials and business model, understand the due diligence process, and demonstrate your success, practice pitching, and close the deal. So once again, deadline is December 22nd. So I come back to today's interview. So I'll start by briefly introducing myself. My name is Bernard Buisson. I will be your host today. I work at École Polytechnique Executive Education. I'm also a professor at École Polytechnique. And I'm very happy to help Photon Hub Europe increase its impact by interviewing some of the people who make the photonic industry grow in Europe. Welcome to this new episode of Photonpreneurs, titled Photonics as the Foundation of the Quantum Internet. And I'm very lucky today to welcome Mr. Gregoire Riberdy, who is the co-founder and CEO of Idée Quantique. Idée Quantique is a company which celebrated its 22nd anniversary this year. So a long life for a company in this industry. Dr. Riberdy, you are also the recipient of several awards, such, for instance, as the 2001 New Entrepreneurs in Technology and Science Prize, the 2002 De Vigier Award, and the Swiss Society for Optics and Microscopy 1999 prize. At the end of 2005, you were selected as one of the most innovative individuals in information technology worldwide by the World Technology Network. And in 2018, you were selected as a Swiss digital shaper leading digitalization in Switzerland. And finally, with the other co-founders of Idée Quantique, you were awarded the Medal of Innovation in 2017 and the Impact Award in 2019 by the University of Geneva. So congratulations, obviously, for this long list of awards. Uh,
Thank you, Bernard.
so let's start with the beginning. I saw you studied at EPFL and also at the University of Geneva, where you did your PhD, and the University of St. Gallen as well. What did you study? So you studied several subjects.
So EPFL, I did a master's in physics, and my master's diploma was on photonics, Bragg gratings in optical fibers. So as you know, I always liked photonics, and then and my PhD was in the field of quantum cryptography. So essentially, quantum optics applied to information security, which is one of the main area where IDQ is active. Now, I always liked applications more than basic research. And so even though I did a PhD, I looked at ways this could be applied. And that's why I also did a business degree on the side in order to be ready, to be an entrepreneur, I guess.
Okay, but what was the stage of the technology at the time?
Yeah,
It was a nascent technology.
Yeah, exactly. So quantum cryptography, the theoretical idea goes back to 1984. But there were two researchers, Charlie Bennett and Gilles Brassard, proposed the idea of doing communication at the single photon level. And if you do at the single photon level and have the proper encoding of information, then you can take advantage of Heisenberg uncertainty principle to make sure that if someone intercept the communication, then you can detect this interception. It's the idea that you do communication with fragile objects, and interception it becomes a perturbation. And so theoretical idea in 84, and then in the early 90s, there were the first experimental people that looked at this and said, well, maybe we could actually realize a demonstration of this. And there were two groups. One was British Telecom in Ipswich, and the other one was the University of Geneva, with support from Swisscom, so also another telecom company in Geneva. And so there was a first PhD student in Geneva that did a first demonstration of quantum cryptography. And I came in 97 as the second wave of PhD student, in a sense. And my role was to take an experiment that took a big optical table, shrink it, to put it in a box, in a rack, so that we could take it to telecom stations and do systematic measurements on real optical fibers installed in the field.
But at the time, obviously, we are talking about prototypes and experimentations, but there were no services based on these technologies. Huh?
No, you're right. And at the time in the 90s, the big challenge was that single photon detectors required cryogenic cooling. We used liquid nitrogen to cool avalanche photodiodes to reduce the noise and use them in so-called Geiger mode, where you have amplification that enables you to detect single photons. And my work, of course, liquid nitrogen is not ideal for application. So my work was to take these detectors and replace the cooling using Peltier coolers, so thermoelectric cooling, so that we could have a device that you just plug into the wall. And so that was one of the things I did during my PhD thesis. And at the end, in 2000, we had a prototype that worked, two 19-inch racks. And it worked well. There was some interest in this kind of application, and that's why we decided to start ID Quantique.
Okay, but more so, if I understand properly, you jumped almost directly from PhD to co-founder of a startup.
Exactly. That's what I did. And I've already mentioned, I've always been more interested in applications than just basic research without direct application. I think also that I would not have been a good researcher because I maybe lack the long-term stamina to take a topic and dig deeper and deeper. But I've always been excited by multidisciplinary projects. And when you take a prototype and want to turn it into a product, that's really a multidisciplinary project. You need to add software to make everything easy, to replace, the PhD student that normally operates an experiment by some software that allows it to automate. You need to do some mechanical engineering to fit everything in a box, to do thermal simulation to make sure. So this kind of things is always what excited me. When we decided to start the company, actually, we were approached by an American company, which was one of the first companies started in the field of quantum technologies. It was a company called Magic Technologies, and they wanted to develop quantum technology products. And initially, they wanted to build a quantum computer. They realized relatively quickly that it was a bit soon. And so they said, okay, what is mature in the field of quantum technologies? And quantum cryptography or quantum key distribution quickly came up on their list as a relatively mature technology. And so they looked around in the world and say, who's good at this? And they came to Geneva and said, could we license the technology that you've been developing at the University of Geneva? So with my two PhD advisors and a third colleague, we discussed a bit. And after a while, we said, oh, okay, so if there is some interest for this technology, do we want to go with these people or should we do it on our own? And we decided in the end to do it on our own. And my colleague, an engineer, and myself, we left the university and started working on it at IDQ.
And so you created the company with your two PhD advisors and another colleague.
And an engineer colleague, who was able to build products. I'm a physicist. I can do a little bit of everything, but nothing completely. And so I needed an engineer that could actually be in the team and make products. Because one of the challenges we had at the time in 2001 was that venture funding was not very developed in Europe. It was the early days. And the second thing, it was just after the telecom bubble. And so even in the US, funding was scarce. And so we had to bootstrap. And how can you bootstrap? Well, you need to generate revenues quickly. And so we had to develop products very, very quickly. And that's why it was important to have an engineer in the team.
Okay. But at the time when you created the company, so beyond taking advantage of an opportunity, did you have some sort of long-term vision at the time already or not?
Yes, I guess yes, because quantum technologies, even at the time, we knew that it was early on for quantum. So we had to have this long-term vision. I think we underestimated how early we were. And in retrospect, I often say that we started IDQ 15 years too early somehow, but we managed to survive. But yeah, of course, we had, the idea is that we develop solutions that make data communication secure against quantum computing. And so the vision was to say, one day there will be a quantum computer. This quantum computer will change the cybersecurity landscape, and we need to prepare with a new set of solutions that can protect information in this world. And so it was we really had a lot of a vision. But I think something that we did right is that we didn't focus only on the vision. We also stepped back and said, okay, the vision is nice, but what about the next 3, 6, 12 months? How are we going to bootstrap? And we brought very quickly products on the market, which I think was the right choice to do.
And so can you tell us what were your very first products?
So I guess the very first product was a single photon detector. I mentioned already that doing single photon detection at the time, when I started my PhD, required cryogenic cooling with liquid nitrogen. And so we developed a simple detector that was, you could plug in the wall and it would work. And with that, we were able to do a lot of experiments, both scientific experiments as well as quantum cryptography. So in the group in Geneva, there were some people doing Bell inequality testing, some fundamental research testing entanglement, and me doing more applied things. And so we were quite advanced in this field of so-called quantum communications. And so some other professors came to the University of Geneva and said, could we buy some detectors? Because that's the difficult part. And so with this, these requests, we decided to develop a single photon detector that would be a device that you plug and you can just use it easily. And you know, it's funny because the very first order that we got, the company did not exist. The product had not been developed, but somehow we were in the process. And so we made an offer to a university in the US that asked us. And then a few days later, we got a fax back. You know, it's the time when people are still using fax. We got a fax back with an order for $200,000 for 8 detectors. So a big amount. And so we decided then after that to create the company and to hurry up, and also to develop the product. And we gave a delivery time of 6 months. And in the end, we were able, I think, to deliver these first 8 products with just 2 weeks delay. So we were quite happy with that.
Wow. Okay. And so when it comes to the location, so my understanding is that you created the company in Geneva because you were close to the University of Geneva.
Yeah.
And so
And that's been
you could
very important. You know, the collaboration with the University of Geneva. We, as a small company, and I would say even today, we don't have really resources to do a lot of research. We do development of products, we do industrialization, but the research is really done at the university, and we have a win-win collaboration where once something has been demonstrated in the lab and it looks like it's useful, then we talk to the tech transfer office, we agree on conditions, and we take this and industrialize it. And I think it's a good model.
Okay, but it's does it fit into the classical spin-off model or not? Would you say?
Yes, I would say so. The only thing is that I guess nowadays you would be able to raise funds earlier, and so you would start by more focusing on a business plan, and you would not have an approach with bootstrapping the way we did it. I guess when I look at startups now, they have the ability to raise funds, seed money much faster. So things have changed a bit.
Yeah, probably. So let's talk a few minutes about inequality today. So what are the numbers you can tell us of basic numbers and things such as number of employees, for instance? How many people do work with you today?
So currently the company has about 130 people, 90 people in Geneva in the headquarters. And then we have a second largest location in Korea with 20 people, and a few people here and there in the US, in Singapore, etc.
Okay. And these people, what are their what's their typical profile?
Well, you know, there's a mix, because as a company you go from development to manufacturing. So we're a full function company in a sense, but the basic, we start with physicists that need to be able to understand the quantum processes that we want to exploit to build a product, whether it's a single photon detector, a QKD systems, or random number generator. And then engineers. And that's one of the important things in the field, is that it's multidisciplinary. So you need physicists and engineers to work together. And then we have people doing manufacturing. We have so all the function of a company, and all the way to salespeople and marketing. And I think that's also, somehow at the two extreme, at the R&D side and the sales side, that's where you need multidisciplinary people. So, somehow in the middle, it can be relatively specialized. But R&D, I mentioned that already, you need physicists that understand engineering, or vice versa, engineers that understand quantum physics. And in sales and marketing, you also need people that understand enough of the technology so that they're able to explain and promote the products.
And so beyond the technological expertise, would you say that there is such a thing as a company culture or company values which are specific to ID Quantique today?
Well, so it's hard to say if it's specific to IDQ, but one thing that we did a lot in the past and still do is that we like to have company events and parties, celebrate events, celebrate, work hard, but then also celebrate together. And I think people enjoy getting together and celebrating together, which is which are always important milestones in ID Quantics year.
Okay. Maybe one word on IP. So how important is intellectual property and patent for your business?
So it's quite important, and I would say it's been very important from the beginning, because when we started the company, it was based on a patent invented by the University of Geneva, but held by Swisscom. You know, Swisscom was providing the funding at the time to the University of Geneva, and we needed to take a license. And a lot of the discussions at the beginning with Swisscom was whether they should give us an exclusive license or non-exclusive license. And Swisscom was saying, we want to give you a non-exclusive license because we don't think that a small company in Geneva can maximize the potential of this technology. And then at some point we started talking to investors, and the investors said, oh, but you don't have exclusive access to the patent. And so you know, it's something that we've been discussing from the very beginning. There was this patent. It was a very important patent. And in the end, we managed to convince Swisscom to grant us an exclusive license, which was then important in securing a funding round. So from that point, then we've filed a lot of patents, and some have already expired, you know, 20 years since the company's been around. So we've seen already a few waves of technology patents, but we continue to do this. And I think maybe one important milestone on this topic is the fact that in 2015, we hired our first internal IP manager. So we have someone in the company that is in charge of managing IP, but also seeding ideas, you know, because one of the challenge I feel with patents here is that very often engineers and physicists say, well, but you know, this is obvious, you cannot patent this. Everybody does this, you know. And so helping engineers understand what is innovative, what is novel, what can be patented is an important task. And so we decided to do that very actively. And we currently hold a patent portfolio of more than 200 patents.
Oh, so you have a broad portfolio.
Yeah.
Okay. Okay, so we are going to switch to the main activities of ID Quantic. First one being random number generation. So can you explain us what role Photonics plays in random number generation and why it's an important technology in this matter?
Yep. So generating random numbers is useful in many applications. You can think about security, generating keys, passwords, but also numerical simulations, Monte Carlo simulations, and other applications. And typically a computer is a deterministic device. And so you need a source of entropy, a physical process to produce randomness. And so the idea, since quantum physics is fundamentally random, you know, it makes sense if you can to use a quantum process in order to generate this fundamental entropy. And so what we did, and actually, you know, what's interesting is that I'll explain afterwards what quantum key distribution is. It's a different kind of solutions, but somehow it's applied to cryptography, to securing communication. And in the late 90s, when we had funding from Swisscom, and Swisscom told us to talk to other cryptography companies about what we do to see if this was useful. And the feedback of these companies, they said, oh, quantum cryptography, we understand nothing about it. But you know what would be useful is to have a good random number generator. And so we developed a random number generator essentially based on a simple optical process, which is you send photons one by one on a 50-50 mirror. And then depending if the photon is reflected or transmitted, you call that a 0 or 1, and you repeat that very quickly. So it's a simple process. Of course, there are lots of tricks and details in practice, but nevertheless, the idea is that. And so that was one of our first products that we developed, we commercialized.
But basically, so it's a way of delivering numbers which are really random and that nobody can predict. That's the idea.
Exactly. And essentially where the source of randomness, you can you can prove that the process that you're using is fundamentally random. And so initially it was a box, I don't know, the size of a small PC. That was what we developed. And we sold a few, and some customers told us it's great, but it's a bit too expensive. Just to give you an idea, at the time, the price was 10K, 10,000 euros, roughly speaking. So we said, okay, let's develop a second generation. And we made it smaller, like a USB device or a board that you put in a server. And we divided the price by a factor of 10. And went on the market. So and we started selling this. And what was interesting, there was a bit of luck there, is that in the early 2000s, there's a market that was developing. It was everything about gambling online, casinos, poker games. And so these people, they were running games on servers, and they needed a good source of randomness for these games. And so that allowed us to start selling a reasonable fair amount of these devices. And
which year was that? Sorry,
I think
approximately.
It started taking off in 2004, really, in terms of reasonable volume. And that's really when casinos were going online.
Okay, so no, I understand that casinos want to make sure that their games are really random. Yeah.
Exactly.
Okay. So I've heard too that you you supply companies such as DocuSign. This technology is used by DocuSign.
Yes. So
can you briefly describe how it works, how your technology has been applied by DocuSign?
Yeah, so we continue to improve the technology, and so in 2020 we released the third generation of our QRNGs, which are chips. So now it went from a small PC to a matchbox to now a chip, and this allowed us to address new markets. So you mentioned one, DocuSign. Here the idea is essentially that DocuSign has some servers where they need to do certified signatures, and so they apply a lot of cryptography. They need good keys, and so we put a board into the server to generate all the encryption keys. So that's one example. But I think a very exciting application is also one where we put a quantum chip, into a Samsung smartphone, and so the smartphone has the capability to generate random numbers based on a quantum process.
And I saw it's a specific model Galaxy, Samsung Galaxy phone, huh?
Exactly. They call it Galaxy Quantum, so because of the quantum chip, and it's available only in Korea. It's something we did with our partner SK Telecom, which is a telecom operator in Korea. But nevertheless, it's a nice application and also a nice demonstration that quantum technologies are ready for prime time. Sometimes when people talk about quantum, people think about, oh, it's science fiction, it's not ready, not for today. Actually, no. What's interesting is that there are some quantum technologies that are ready for prime time today.
But so if I come back to DocuSign, it's a proof that quantum technologies are used by millions of people already.
Exactly. No, clearly. Exactly. Yeah.
Okay. A few words also, obviously, on quantum safe security and quantum key distribution. So what are these technologies?
So this is
How
really
do they work?
this is really what was the origin of IDQ, ID Quantique. It's the idea is that quantum technologies will allow to build new computers that are quantum computers, and these quantum computers will bring huge benefits. They will allow to run certain algorithms much faster than on even the best high performance computers that we have today. But they also have a dark side. One application is that it will allow to break the mathematics of current cryptographic algorithms. And so we need to find a new set of technologies which is resilient to quantum computing. And that's called quantum safe cryptography, everything that is safe against quantum computers. And so one way to be quantum safe is to do communication over optical networks at the single photon level, so that you exchange a string of single photons, you encode bit values on these single photons, and somehow if someone intercept these photons by measuring them, they will introduce errors, and the emitter and the receiver will be able to detect these errors. This is what's called quantum key distribution. And the reason why it's called quantum key distribution is that you don't prevent interception, but you reveal it, and you reveal it after it happens. So you don't want to use this technology to send valuable information, because if you did that, you would know that you've lost information after losing it, and that's not the goal. But instead, you send a random sequence of bits. You can check whether it's been intercepted or not. And once you know that it has not been intercepted, you use it as a key, as an encryption key that is shared in two places and that can be used to encrypt traffic. And that's why the name quantum key distribution, which is quantum safe.
Okay, but that's a way to make sure that communications are 100% safe.
Exactly. That and 100%, I prefer to say that they are long-term secure. The benefit really here is that with traditional cryptography, security is based on the computing power of your adversary. And so security you have to
you have a more or less a date of validity, yeah?
Exactly. So the security you have today is not the same as tomorrow, 5 years, 10 years down the road. Which is okay with a lot of applications, but in some applications where you need long-term security, it's a problem. And so with quantum key distribution, what's nice is that the security is based on the laws of physics somehow, and we don't expect the laws of physics to change in the future. And so the security level will remain the same.
Yeah, okay. So I heard that you installed, well, you started to be active in this field as early as 2007. So what did you do at that time?
So the first QKD system we actually sold in 2004, but we sold it to a university and that were doing research. But in 2007, it was an important milestone because it's the first time that we had a real user, a user with security requirements, but also availability requirements. They were using it and it had to work. It couldn't fail. And the application was actually in Geneva. It was used by the IT department of the state of Geneva, which wanted to use it to secure communication in the context of Swiss elections, where votes were being counted in one location and the result had to be sent to a different location. And so you can imagine that if the state of Geneva had been late to deliver vote results on that particular day in 2007, it would have been a big problem. And so it was very important to have something working. And in that sense, it was an important milestone.
Okay. And so who are the industry, which are the industries which are today users of this particular technology?
So I would say
there's a long list today. Huh?
Yeah, but I would say there are two main industries right now. First, there are industries that are the telecom operators that want to use it in their own network to protect their own network, or to build network which they can use to offer value-added services in terms of communication. And here, we see a lot of or more adoption in Asia. So South Korea with SK Telecom, Singapore with Singtel. There is a little bit of adoption in Europe, but I'm always a bit disappointed by the lack of courage that European users show. But I guess that's
but it will come. Huh?
It will come, but
yeah.
But it'd be great if Europeans wanted to be first sometimes also in this kind of things. But anyway, so one area is telecom operators, and the other area is industries that have long-term security requirements. So you could think of finance, you could think of governments, and this kind of verticals.
Okay. I've seen this strange wording which is called quantum panic. What is this?
Yeah, so the quantum panic is to say one day when there will be a quantum computer, the cryptography that we use today will become vulnerable.
Obsolete.
And so obsolete, exactly, very good expression. And so if we don't prepare, then all of a sudden, the security of our infrastructure will collapse. And the important thing is that organizations have to start a migration to quantum safe solutions early enough. And it's not something that's going to happen overnight. It's not about downloading a new software. It's about rethinking how your information security systems are based and using the right set of technologies where it makes sense. And sometimes I must say I'm a bit concerned that, again, in certain countries, people don't take this risk seriously enough.
Mm. And in this particular technology, who are the other players? In which continent are they? So I guess there are players in probably a lot of players in Asia today, and in the US as well.
Yeah. So US not so much, but Asia, you're right. And China has been the first country to drive deployments, large-scale deployments of this technology. But now it's a closed market. They want to use only Chinese solutions. They're not very transparent. So we don't really know what's happening in China, except that there's a lot of investment. Outside of China, I would say that with ID Quantique, there's Toshiba, that is the second most advanced company. And then there are a few startups in Europe. US are lagging a bit behind. In the US, most investment went into quantum computing, a bit less into the field of quantum communications, but I'm sure they'll wake up and catch up.
Okay. So among the technologies we have to discuss, there's also quantum sensing.
Exactly.
Can you explain us in simple terms, if possible?
Yeah.
What this can be?
Yeah, so quantum sensing is essentially detecting single photons. And I mentioned already that when we started the company, the first product was a single photon detector. And so since then, we've developed a whole range of products for different wavelengths, different kind of applications, single photon detectors. More recently, the most recent addition to our product line is a range of single photon detector based on superconducting nanowires. And these are really amazing detectors. If I remember when I was a PhD student a long time ago, it would have been my dream detectors at the time. When I was working in the lab, you always had to adjust your experiment because detectors were not performing as well as you hope. And now with these new detectors, they deliver all the performance that people need. So for us, it's very important first to enable researchers to continue developing new applications of quantum communications. And the second thing is that these are building blocks of more advanced applications where IDQ will also play a role. And sometimes people talk about quantum internet, which is essentially a network connecting users and devices at the quantum level, end-to-end quantum in a sense over long range. And IDQ will be one of the key players in the field of quantum internet based on our experience in quantum key distribution, but as well as our mastering of enabling technologies.
But I saw IDQ got an award, another award in 2022 called the Innovation Award in the Quantum Technologies category.
Yeah.
For this, yeah.
Thank you. Yeah, nice. I appreciate it. Amazing detectors.
Okay, and so when it comes to this particular technology, who are the other players? Where are they located today?
In this case, they're more or less all over the world. There are some in the US, there are some in Europe. So it's pretty spread out. I would say it's interesting. This particular technology of superconducting nanowire was actually invented in Russia in the late 90s. And old Russian experience in special materials, and so it came from Russia, but that was never well industrialized, and so it worked, but more as a lab demonstrator. And so now there are players in various countries that actually build industrialized product based on this.
And so how do you see this market grow in the coming years? So you think it's going to become probably very significant, huh?
So it's a nice market. It's growing more linearly than
Mm,
the cybersecurity market, the other
mm,
applications,
mm,
because it's rather specific. It's really academic research, some industrial labs also.
mm.
But it's a nice it's a nice linear growth over time.
Okay. So I'm going to move away from technologies and maybe come back to the company itself. Um, can you can you tell us what was your last round of fundraising when it happened?
So the last significant round was in 2018 when SK Telecom, so this
Mm,
South Korean telecom operator, approached us and wanted to be the main investor in ID Quantique. Somehow they had identified quantum communication as an important technology. They
mm,
wanted to play a role and have access to this technology for their own use, but also play a role in the global market. And they had a quantum technology lab, but somehow they wanted to accelerate, and so they approached us and said, "Are you interested in an investment? Then we could bring our team with your team together and make the global leader in quantum communications."
Okay, so they are one of your shareholders today.
Exactly.
Okay. So how do you see the coming years, the coming 5 years, for instance?
Yeah.
Um,
So I
what?
mentioned ID Quantique was founded 15 years too early. So essentially that means that things start getting exciting since let's say 5 years, 5 6 years,
Mm,
and that's linked to the progress in quantum computing,
mm,
and also the fact that quantum has become a strategic area for a lot of governments worldwide.
mm,
So we've seen some emergence of a more stable market or more defined market, and we expect this to continue to expand. Next year will be an important year because in the US there will be for the first time a standard to about what kind of technologies need to be used in order to be quantum safe, and that means that somehow that's for the US government, but somehow the US government sets the trend for a lot
mm.
of other governments. And so we expect that maybe not immediately next year, but from 25, there will be an acceleration of the market. So we feel that things are going to be exciting in the next few years.
Mm. Okay, so it's going to become compulsory
Exactly.
for a number of industries, huh?
Exactly.
Mm. Okay. Um, is there any specific project or topic about which you're especially excited for the coming years?
So I think, we've talked a lot already about application of quantum technologies, but one thing that I find particularly interesting is the fact that there are also spin-off applications in completely unrelated fields. And one example is the fact that the European Space Agency selected us in their project for Ariane 6, their new rocket launcher, which is a bit late, but hopefully, eventually it will be launched. And the launch of Ariane 6, the triggering of the different stages and different engines actually uses optical fiber. The cables, the systems have been replaced, copper cables into optical fibers because it's lighter and less prone to electrostatic discharges. And essentially, you send a bright pulse of light into an optical fiber, it's absorbed, detonates some explosive and starts the engine or triggers the separation of the stages. And so what's important is that before you launch a rocket, you need to test it. How can you do that? You could do an optical time domain reflectometer. You send light and look at what comes back as a function of time, but you want to do this without triggering the engines. And so you need to send And if you send weak light, you need single photon detectors. And so we developed, based on the single photon detectors that I discussed earlier, we developed a very specific optical time domain reflectometer to be used by the European Space Agency for Ariane. And so one day, when Ariane will be launched for the first time, one of the green lights in Kourou, in the central control room, will come from one of our equipments, which is a spin-off from quantum technologies.
Okay, so that's how we have photonics in the space industry.
Exactly.
Okay. So still on ID Quantic, so can you tell us maybe about what's your vision is, maybe let's say 10 years from now, where do you see ID Quantic?
Yeah, so 10 years from now, I think what is clear is that there will be quantum computers. And so the need to have quantum safe communications will be by default somehow. And so ID Quantic it will be one of the key suppliers of these quantum communication technologies to offer these secure communication, but also there will be a need also to build a new type of networks in order to connect quantum processors remotely, to allow them to be connected to form bigger devices. And so IDQ, our vision is to be the quantum networking company providing this kind of solutions.
Okay. And if you look back at the 22 years of ID Quantic, what would you say were the main milestones or turning points in the history of the company?
So I think, first use cases, we already discussed what happened in 2007. These are very important validation point, I should say, both internally and externally. But there's been also important milestone related to funding, because when you the field of deep tech, you can bootstrap to a certain level, but eventually you need some funding. And we were able to raise funds at different stages in our history. Essentially, we are now a bit like a typical company, except that we did it over a longer period of time. But we rose angel round to after bootstrapping, then Series A, then strategic investors. So nothing very special. One challenge, I think, which was faced by us and is also probably faced by a lot of companies, again, probably a specific challenge to Europe, is the lack of growth capital. I think, while 20 years ago it was hard to find any money, now it's relatively easy, or it's easier to find the first 5-10 million, the Series A, the seed at Series A. When you need to go to the next level and raise, I don't know, 50 million to be the leading company worldwide, it's still more difficult in Europe. And I think it's something that I hope Europe can address in the future.
Yeah. So going back to your personal experience, so as I said, as we discussed, you went directly from being a researcher in physics to being a corporate executive. What was or what were the biggest challenges associated with this type of change?
I think, I was lucky because I had time to learn and evolve, because we started early. For a long time, there was not a lot of competition pressure. And so it gave me the time to learn and evolve. And maybe today it could be more difficult for some people. But in general, I think if I had to mention one personal challenge, I think as a CEO of a company, and it's probably not specific to pure science, but as a CEO of a company, you are really at the intersection of the image you project outside and the knowledge that you have of the inside. And somehow you have to be very optimistic and project a great image outside, while at the same time, all the challenges you face and all the problems and all the technical problems you need to solve and all. And so it's sometimes it can create a cognitive dissonance, for the CEO, because you really you need almost to have two personalities: one speaking to the outside, saying everything is fine, and one just absorbing all the challenges that you face in the inside.
And so, finally, maybe so, what advice would you offer to young as scientists, engineers, maybe in physics, and people who consider starting their own technology company? What would you tell them?
I don't know if that's really advice, but something I heard often and I still hear is that people are afraid to take risks, that it's a risk to start a company. And I never looked at it as a risk. I think it's so much more of an opportunity, because even if you fail, you will learn so much in the process that it will add, such a rich experience that it can only be beneficial. And so I think I would be to say, don't think about risk at all. Think about opportunity. And when we hire people at IDQ, I see how important it is to look at people that have a special experience. So somehow, even if you start a company and you fail and you want to find a job, this special experience will make you a special person, and will make you someone that companies will want to hire. So yeah, I guess that's what I can say.
Okay, wonderful. So thank you very much for your time, and obviously best of luck to ID Quantique for the coming months and years, which should be pretty busy.
Yes, indeed. Thank you, Bernard.
Thank you.
Thank you.
So we're going to stop here the